Hey guys, Mr. Milton here. Today we're going to talk about scientific notation. At the end of this video, you should be able to write a number in scientific notation, order numbers written in scientific notation, and multiply numbers in scientific notation. Scientific notation is a way of writing numbers that are either very large or very small. We set it up as a times 10 to the n, where a is greater than or equal to 1, so that means it can be 1, and less than 10, which means it cannot be 10. Okay, and so looking at that setup, which of the following numbers is written in scientific notation? Okay, so notice that they all seem like they could be, but actually they are not all written in scientific notation. First thing to notice is that a has to be greater than or equal to 1, so 1 or greater, and less than 10. Okay, so it can't be 10. Anything more than 10 doesn't work. So A will not work because in this case A was 52. Fine. C will not work because in this case you notice that A is less than 1. It needs to be greater than or equal to 1. Alright, so just looking at A, we can eliminate those two options. Okay, other two things to notice is that scientific notation is multiplication. Okay, D does not multiply, it is addition. So we know D is not it. Okay, just because B is all that's left doesn't mean that it has to be right, so we're just going to make sure multiplication N is a number, whole number. Okay, great. B does work. Alright. Writing a number in scientific notation, we want to write this number. What is this? Hundreds, thousands, millions, billions, 5,700,000,000 in scientific notation. Okay, so for scientific notation, remember that what we're going to do is we're going to move our decimal to the place so that the number is greater than 1 and less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I counted 9 spaces, and it took me 9 spaces to move my decimal. Remember that there's decimal in every number from the end in between those two places, so 5.7. Okay, we know that's going to be times 10 to then. This is why I counted spaces. And for me, I just always put this number here. It's 9. And then I think about, is this a big number or a small number? Okay, because scientific notation is either to write large numbers or small numbers. And this is a big number. If it's a big number, then what you're going to do is you're going to make your exponent positive. Okay, and so what I did, as you go through this, is a big number, a small number. We said it's a big number. Where's the decimal currently located? Remember that every number has a decimal. We just don't have to write it all the time. Okay, so decimal's at the end of the number if we don't have a decimal written. Okay, and in this case, we wanted to move it between the 5 and the 7, because that way A would be greater than 1 and less than 10. Greater than or equal to 1 and less than 10. Okay, we needed to move this decimal 9 places. This is my exponent. Okay, is this a big number or small number? Big. Okay, big number means positive exponent. Small number means negative exponent. So you can write that number up there at the beginning if you'd like to and just say, okay, if it's a small number, negative. Big number, positive. Okay, and so now we'll go through the same thought process for this next problem. Okay, so I have my decimal. In this case, it is written. I'm going to see how many places I have to move it. 1, 2, 3, 4, 5, 6, 7. Move it 7 places to get it between 3 and 1. Okay, because that way A would be greater than or equal to 1 and less than 10. Times 10. I'm going to write 7 up here. Now I have to think, is this a big number or a small number? This is a small number. That means that's going to be a negative exponent. Okay? And so that's how your thought process goes into how you write from standard notation into scientific notation. Alright, standard notation or decimal form, either way, You should be able to recognize what they're asking there, or recognize both of those terms. Okay, example 1 says write 5.21 times 10 to the 4th in decimal form. Okay, so we're standard notation. So the exponent is a positive number. So this is a big number. And that means I'm going to move the decimal to the right. So I'm going to move this to the right 4 times. 1, 2, 3, 4. Okay, and I like those loops because they show me how much open space I have. So 5, 2, 1, 0, 0. 52,100. If the exponent were negative, everything would be switched. Negative number, and move decimal to the left. I said negative, but sorry, I thought it was switching that. So it would be a small number and move to the left. Okay, so write 9.713 times 10 to the negative third in decimal form. I'll have you guys do that on your own, so make sure you do that for me. Okay, backside. To order numbers in scientific notation, you must first make sure all numbers are in scientific notation. Okay, or I'll say scientific notation, but really it's the same notation. Okay, either standard or scientific, either one doesn't really matter, but scientific will probably be easier, especially when you're dealing with like negative 24 to the negative 24 power. You don't write all those in standard notation. Okay, once in scientific notation, look at the exponents first. Okay, the exponents will tell you what the larger and smaller numbers are. And then if the exponents are the same, the tiebreaker is the base value, and that's the A value. Okay, the A is the tiebreaker. So here it says which particle is not in scientific notation. So just looking at it really quickly, you might say they're all in scientific notation, but see the proton is not in scientific notation. Okay, the decimal needs to be between the 1 and the 6. So since I'm making the A value 1.6749, I need to make the exponent decrease by 1, because this tells me to move left 25 times. Well, if I move left 1 time, it actually should be telling me to move left 24 times. So I need to make the exponent smaller by 1. Okay, and I can see now that that means smaller by 1. Okay, so since I'm making the A value smaller by 1 spot, okay, I need to make sure that I'm keeping the exponent smaller by 1 to keep it balanced. Okay, and so now what this number is 1.6749 times 10 to the negative 24. Okay, so since I'm going from lightest to heaviest, the lightest or the lowest number is the electron. Okay, and I can tell that right away because it has a negative 28 exponent. Okay, now I have to deal with neutron or proton. Which one is going to be the lightest? Okay, they both have the same exponent, and so now I have to see which is a small number. So 1, 6, 7, 2, 4. Okay, so this is 2, this is 4. 2 is smaller. So the neutron goes next, and then the proton. Okay, so again, looking at making sure they're all in scientific notation, and then just measuring off and comparing the numbers of the base value. Okay. Okay. Now here's all that scientific notation you've probably been used to and used in science classes either this year or in the years in middle school or previous classes. This is kind of new for you. And this is multiplying with scientific notation because you probably weren't asked to do this very much in previous classes. Okay, now we're going to go through this, but I want to tell you that this is not the distributive property. The the distributive property is used with addition and subtraction here, not multiplication. Okay, so essentially this is just you being able to group in a way that's advantageous for you. Okay, because all this is multiplication, 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 multiplication. And no matter what order you multiply in it, you get the same answer. So what we're going to do is we're going to say, hey, it'll be easier for us to multiply two regular numbers together and then write it in scientific notation than to put it in scientific notation and then multiply and then have to do scientific notation again. Okay, so essentially for this problem, I'm going to tell you, hey, do 12 times 9.1. And then do the scientific notation. Because 12 times 9.1, oops, not divided by. Let me do that again. 108. 12 times 9.1, 109.2. Okay, 12 times 9.1 is 109.2. Now we have 109.2 times 10 to the negative 7. Okay, now this is not in scientific notation. Oops, sorry guys. 109.2 times 10 to the negative 7. This is not in scientific notation because 109.2 is not greater than or equal to 1 and less than 10. So we need to make this fit into that window. And so we'll move over twice. Okay, so as of now, this exponent is saying move left 7 times. Well, I moved left 2 times. So what's this exponent going to say now? Well, you already did it twice, so don't move left 7 times, move left 5 times. So it'll be 1.092 times 10 to the negative 5th. And so now I have it in scientific notation. So again, the rule really is multiply the regular numbers first, then do the scientific notation. Okay, the ordering at the beginning will tell you something a little different, but make sure that you do that. Okay, one more example for you. We have 0.5 times 1.2 times 10 to the 8th. Okay, so again, I'm going to say it'll be better for me to do 0.5 times 1.2 first, and then times that by 10 to the 8th. Because 0.5 times 1.2 is 0.6 times 10 to the 8th. Now, this is not in scientific notation because 0.6 is not greater than or equal to 1. So I need to move right once. This exponent says, hey, move right 8 times. And I moved right once. What's this exponent going to tell me now? Okay, move right 7 times. Alright, that's scientific notation. See ya.